Hello students, welcome to Edubbey Global Solution. In our mathematics class again, we're going to be looking at another topic which is trigonometry, and in this class we're going to be consider SOHCAHTOA, Pythagoras rules, and we have past questions that backs these topics up. Okay, we have so many activities in this class, and interactive content is going to be serving as a guide, okay, for this class. So let's start with trigonometry. Okay, when you're talking about trigonometry ratio, we have some basics, and the basic trigonometry ratios that we are going to be considering here is sine, cosine, and tangent. Okay, so for this ratio related an angle of a right angle triangle to a ratio of the length of the two sides. So under this trigonometry ratio, we're going to be looking at the right angle triangle, and we're going to be looking at each size, each length of the size of the right angle triangle. So the longest side, which is always opposite to the right angle triangle, which we have here, we call it hypotenuse. Okay, the side opposite the angle, we call it opposite side, and the side that is next to the angle is called the adjacent side. So for a right angle triangle, we have three sides. The longest part of it, we call it hypotenuse. The one opposite the hypotenuse, we call it opposite side. Okay, and the one opposite the opposite side, we call it adjacent side. Let's check. Okay, our arrangement is good, and we see the illustration in this picture below. So now the first thing we're going to be doing here is we are going to be looking at the trigonometry ratio one after the other. So we are starting with what? We are starting with tangent. And when you're talking about tangent, for a tangent, there is an acronym that we used to use. The acronym is SOHCAHTOA. SOHCAHTOA. So under this, we are considering TOA first. TOA says that tangent, okay, tangent or C or tan theta, that is more subscript name for it, is opposite side. I'm going to shorten it over adjacent side. We've made mention of the right angle triangle, that this is the opposite, this is the hypotenuse, this is the opposite, and this is the adjacent, depending on where the angle is actually facing. So wherever the angle is facing is what we call the opposite. So if the angle is facing C up here, then 5 centimeter here is going to be the what? Is going to be the opposite. Okay, so for this now we have tan C to be the length of the opposite divided by what? Over the length of the adjacent side, and that's what makes tan C. Now if you look at this, we have we don't have opposite here. Okay, we have adjacent to be 5 centimeter, and our opposite here is what? Our opposite is 4 centimeters. So the best thing for us to make use of here is what? Is tan theta. So we are making use of tan theta equals to, okay, so the question says you calculate the angle BAC. So that implies that we are calculating angle S. So we have opposite, okay, over adjacent, right? So it's going to be tan S. That is what we are calculating. Okay, opposite is going to be 4 centimeter, and the adjacent is what? Is 5 centimeter. So having that, then we can now say that what is 4 divided by 5? Okay, so 4 divided by 5 will give us 0.8. So we have tan x to be 0.8. Now we want to get x. It's just like we are dividing this side by tan, and you are dividing the other side too by tan. So by that plus that tan, we cancel tan. And under indices, we have what? We have a rule that says that 1 over a is written as 1 inverse of a. Okay, so the same thing applies to this. This s cannot be written as 1 over tan 0.8, right? So if that is this, we can write it as s equals to arc tan theta, arc tan 0.8. Okay, so that implies that if you have to press this, you are pressing shift tan on your calculator, then you press 0.8. So if you have shift tan 0.8, our answer is going to be 38.7 degree. That is to 1 decimal point. Okay, so we have it to be 0.7 degree, and that gives us the degree for x. So let's quickly put the right answer inside the boxes we have here. So it's going to be tan C is length opposite over what? Over adjacent. So it's going to be 4 divided by 5 here, and that will give us 4 divided by 5, having getting that with the time, we're having to be 3.87. Okay, now let's look at the next one we are going to be looking at here is what? We are looking at sine. I'm going to be calling it sine theta, okay? So for the formula for sine theta, it's going to be, let's use this acronym. This one will help us out. We have so, okay? So that means that sine theta equals to opposite, I'm shortening it, over adjacent. So then that implies that the length of the opposite side divided by the length of the what? Of the okay, I'm talking about sine, right? So it's going to be so, okay? So it's going to be opposite over hypotenuse now, not adjacent. Okay, so we have it to be opposite over hypotenuse, the length of the opposite side divided by the length of the hypotenuse side. Now let's look at it here. We have opposite, we have hypotenuse, so it's going to be opposite divided by hypotenuse. Now we have a question that has to do with this. We have to calculate the length of the hypotenuse PR. PR is indicated as what? As Q centimeter. Okay, so since we said tan theta equals to opposite over hypotenuse. Now, okay, now look at this. The angle is facing this side, so this is now the new opposite. So it's going to be tan theta here is what? 118 degree. Okay, so we have 18 degree divided by 11 centimeter over Q centimeter. So we cross multiply because we are looking for what? Q. So it's going to be sine 18 degree multiplied by Q centimeter equals 11. What is sine 18 degree? That is 0.3090. Then we multiply it by Q divided by 11. So having that now, we can now divide both sides by what? 0.390 Q. Then we have 11 centimeters. So divide both sides by 0.3090, 0.3090. So this can cancel this out. We have our Q centimeter here to be what? 11. Okay, 11 divided by the answer will give us 35. Okay, 0.59. So that's going to be the centimeter. So we approximate it to 3 significant figure or 1 decimal place is going to be 35.68 centimeter, and that gives us the solution to this question. Okay, now let's look at the next slide that we have here, which is what? Cosine. For cosine, the rule is more or less that when you have adjacent over what? Over the hypotenuse. That's the formula for calculating cos theta. Okay, we call it CAR. So this is the acronym CAH. Okay, so that is called cos theta equals to adjacent, I'm shortening it, over hypotenuse. Okay, so now this is the, you see the hypotenuse there and you have the adjacent here. Now we have a question in this. Look at this. We have the hypotenuse to be 20 centimeter and we have the adjacent here, because we look at this, the angle is facing here, so this is the opposite of this angle. The adjacent 27 centimeter. Our theta is what? 62. So it's going to be called 26 degree equals to, okay, adjacent is Z centimeter divided by 20 centimeter. So we cross multiply. So we have cos 62 degree multiplied by 20 degree equals Z centimeter. Cos 62 will give us 0.46955 after approximation. So we have Z multiplied by, okay, multiplied by 20 centimeter. Let's have that equals to Z centimeter. So having that, let's multiply the answer we have here. That is 0.695 times 20, and that will give us 9.3894 centimeter equals Z. So that implies that the length Z is what? Let's approximate to 1 decimal point. That's 0.4 centimeter. Okay, and that will give us the adjacent of this given now. So let's quickly put the right answer into the boxes and let's see what we have. It's going to be adjacent over hypotenuse. Okay, and the adjacent here is what? Is Z. So cos 62 degree rather will give us 0.4695. We multiply 4695 by 20, approximate to 2 decimal points, we have to be 9.39 centimeter, and that gives us it. Okay, now let's look at the next 3 here. We want to look at Pythagoras theorem. We look at the sine, which is what? Opposite over hypotenuse. We look at tan, which is opposite over adjacent, and we look at cos, which is adjacent over hypotenuse. Now we want to look at another rule that we can use for our trigonometry ratio, which is what? Which is Pythagoras theorem. So we say that Pythagoras theorem says the relationship between length of the straight of three sides of a right angle triangle. And we now say that Pythagoras theorem is stated as what? It has to be hypotenuse square equals to opposite square plus adjacent square, and that is the theorem. Okay, where if you have to look at this diagram here, the hypotenuse here is 8 centimeter, and the opposite is 6 centimeter, while adjacent is b centimeter. So you want to rate it, you say a square equals to c square plus b square. Okay, now let's use that rule to solve this given problem. Now if we have that, we say that hypotenuse say Pythagoras rule says what? Pythagoras theorem says that we have hypotenuse square, I'm shortening it, equals to opposite square, okay, plus what? Plus adjacent square. Now from this angle, our hypotenuse is a centimeter, so we have it to be a meter or square, okay, and the opposite is 6 centimeter square, okay, the adjacent is 8 meter rather square, okay. So we have plus in between here, okay. So that is a square equals to 6 times 6 will give us 36 centimeter all square, plus 8 times 8 will give us what? 64 centimeter all square. So having that, we can say that a equals to 36 plus 64 will give us what? That is 100 meter square. So we have it in the square. Okay, now if we have that, then if you want to remove square, then implies that you are introducing square root in both sides. Square root both sides. So we have a square will cancel square root. Now what is the square root of 100? That is 10 meter. And that's the solution for this given problem. Using what? Using Pythagoras theorem. Okay. Now we want to look at angle of elevation and depression. So the angle of elevation is the angle above the horizontal through which a line of view is raised. Right? The angle of depression is the angle below the horizontal through which a line of view is lowered. So elevation means above the horizontal line. When you have angle above the horizontal line, that is the angle of elevation. And when you have angle below an horizontal line, we are viewing it below the horizontal line, then we say it is what? Angle of depression. So now look at an illustration here. We have this, we want to sort out this given problem. Okay, so let's check through and let's see what we have. The base of the tower is 60 meters away from a point X on the ground. Okay, if the angle of elevation of the top of the tower from X is 40 degrees, calculate the height of the tower. So if we have, okay, we have from the ground, they said this was the 60 meter. From the angle of the tower, that is elevation. That means that we are moving up the horizontal line. Okay, we have it to be what? 40 degrees. So we have to calculate the height, which is what? H. Okay, so if we have height to be h, okay, now this is what? This is going to be the hypotenuse, this is opposite, and this is what? Adjacent. Now having that, we have only opposite, and we are looking for opposite, we have adjacent. So the best rule that we have to use under this SOHCAHTOA, okay, is what? We are using tan. Okay, so we have tan theta equals to opposite over hypotenuse. Under this place, the opposite, the theta here is what? Theta is 40 degrees, okay? Opposite is h, and hypotenuse is 60 meters. So we cross multiply, and we have it to be tan 40 degrees multiplied by 60 meter equals h meter. Okay, so what is tan 60 degrees? Tan 60 degrees will give us 1.7321 after we approximate, multiplied by 60 meter equals h meter. Okay, so we have 1.7321 multiplied by 60 to give us 103. Okay, we have 103.9 meter equals h. So the length, the height here is 103.9 meter. So that gives us the solution to the problem we have here. Then let's look at the next solution here. Okay, we have another activity here under the angle of elevation and depression as well. So let's solve and let's see how it goes. An aeroplane receives a signal from a point X on the ground. If the angle of depression of the point X from the aeroplane is 30 degrees, calculate the height at which the plane is flying. Okay, so we have from the ground there is a signal. Okay, so and the angle there is what we are having the angle to be 30 degrees. Okay, so if you have that to be 30 degrees, we are told that the length is 6 kilometers. So it's just more or less like you have a stretch of something like this. Okay, we have this. Okay, we have this is the sketch here now. So we have 30 degrees here. Okay, we have 6 kilometers. Okay, we have to look for the what? We are looking for the height. So having that, you should see that this is going to be the opposite now. We have the hypotenuse, isn't it? And this is going to be the adjacent. So with that, the best trigonometry ratio to use is sine. So we have sine theta equals to what? Opposite over what? Over hypotenuse. So from here, our theta is what? Our theta is 30 degrees. Okay, so opposite is h and hypotenuse is 6 kilometers. So we cross multiply, we have sine 30 degrees multiplied by 6 kilometers equals h. So what is sine 30 degrees? That is 0.5 multiplied by 6 kilometers equals h. Okay, so 0.5 multiplied by 6 will give us 3 kilometers equal h. So h is what? Is 3 kilometers. So let's read the right answer into the boxes. The hypotenuse here is 6 kilometers. Okay, so sine 30 is what? Sine 30 is what? 0.3. And that gives us the solution to the problem. Now let's look at angle between 0 degree and 360 degree. Okay, so to calculate more than one solution of size of an angle using trigonometry, and understanding of the shape of the trigonometry ratio is needed. Okay, so before we calculate any angle of any given size, we must understand the trigonometry graph that is being given. So, but before then, let's look at some of these trigonometry graph. The first one we are going to be looking at is what? We are going to be sine curve. Okay, so the graph of y equals to sine x is plotted where x is the size of the angle in the degrees. Okay, so we have our x-axis and our y-axis. So the x-axis is the size of the angle. You can see that we have 90 degree, 180 degree, 270 degree, and 360 degrees. So the interval on this x-axis is what? Is 90 degree. Okay, so we have the y-axis to be 1 to 2, and we have -1. So, and if you are plotting the sine curve, this is how it's reflect. So the curve goes this way if it is a sine curve. So we say that the graph of y equals to sine s has a period of 360 degrees. Okay, so it repeats itself every 360 degrees. Then a maximum value of 1, which is at 90 degrees, and a minimum value of -1, which is at -270 degrees. Okay, with that we have to solve this given question. Sine 30 degrees equals to 0.5. Which other angles between 0 degree and 180 degree has a sine of 0.5? So what we just need to do is that we have to look at the x-axis based on the interval that we given to us. So if you look at what degree will give us 0.5 apart from 30 degrees, we are told that sine 30 degrees is 0.5. So if you use that calculator, sine 90 will not give us 0.5. That 90 is 1. So if we are checking, let's check for sine 150. We are using interval of what? Interval of 30 degrees. So sine 150 as well will give us 0.5. So under sine rule, another degree that will give us 0.5 is what we call sine 90 degree. And if you want to express that, you can express it as what? Sine 180 degree minus x. where our x here is what? 30 degrees. So if we have 30 degrees subtracted from 180 degrees, that will give us what? 150 degrees. And sine 150 degrees is what? It will give us 0.5. So that's the rule for this. Okay, we are right. Okay, now let's look at the cosine curve. The graph of the y cos equals cos x is plotted when x is the size of the angle in the degree. So the same thing applies to cosine curve. The x-axis takes the values for the size of the angle. So, and the interval we are going to be using here is 90 degrees. So 90 degree, 180, 270, and 360. And that is how the curves goes. Okay. So for the graph of y equals to cos s, it has a period of 360. So it repeats itself every 360 as well. And the minimum value is going to be 1, while the maximum value is what? Is minus 1. And the notation for cos x is what? Is minus cos 180 minus x degree. Okay, so that is those are the fundamental rules for cosine curve. Okay, now we have another activities there. We have cos 60 degree equals 0.5. So which other angle between 0 degree to 180 degree has a cosine of minus 360 degrees? So based on the interval we're going to be using, we are starting with interval of 30. Cos 30 will not give us 0.5. Okay, cos 60 is giving us what? It's giving us 0.5. Let's see what cos 120 says. Cos 120 also will give us what? Will give us minus 0.5. So if that is the case, then cos 120 rather is the answer to this given problem on this curve. Also, for us to get that, then we have our cos 120 to be what? Cos 120 is 0.5. So we can now say that cos 60 equals to minus cos 120, because minus cos 120 will give us minus 0.5, and we have minus 0.5. So minus times minus will give us plus, and that makes it what? Cos 60 degree. Okay, now let's look at tangent curve that we have here. The tangent of y equals to sin x is plotted below, where x is the size of the angle in the degree. So these are the fundamental rules for tangent curve. This is how the curve looks like on 45 degree, on 135, 180, 225, 270, 315, and 360 degrees. So the interval here is the interval of 45 degree on the x-axis. So the tangent graph has a period of 180 degree, no maximum or minimum value. You can see that the curve it doesn't stop at any specific point here, and at 90 degree and 270 degree, I always say that all odd multiple of 90 degree, that is, by the time you have 90 multiplied by 1, 90 multiplied by 2, that's okay, odd. 90 multiplied by 1, 90 multiplied by 3, 90 multiplied by 5, 90 multiplied by 7, and so on. Then the graph will be undivided. That is, it won't have any specific answer. If you look at it here, when we have 90 degree, we don't have any curve of the graph. When we have 270 degree, it doesn't have any solution. And the same thing will apply to 540 degree if you have to go on and on the size of the angle. Okay, so the graph has asymptotic at x equals to 90 degree, 270, and 450, etc. So that implies that at this specific size of an angle on x-axis, the graph does not have a solution set. Okay, now we want to look at solving trigonometry equations. Okay, so the very first thing we're going to be looking at here is we have an activity here which says that angle A is an obtuse angle. If sine A equal to root 3/2, which is written in short form, then we should calculate size A. Now, first and foremost, what is an obtuse angle? Obtuse angle is an angle that is what? That is more than 90 degree, okay, and is less than 180 degree. So what should come to our mind is that the solution that we have to be getting here must not be less than what? 180 degree, and must not be must not be less than 90 degree, and must not be greater than 180 degree. So let's look at what we have. We have sine A to be root 3/2. So let's do that. What is root 3/2? We have root 3 we divided, that is 1.73 7320 divided by 2. So if we divide that by 2, we have it to be 0.8660. So we have, remember we said we have sine A equals to, okay, 0.8660. So for us to get A, that is going to be what? Arc sine 0.8660, and arc sine 0.8660 will give us what? Will give us 60 degrees. Now A cannot be 60 degrees. Why can't A be 60 degrees? Because we said that A is an obtuse angle, and an obtuse angle is more than 90 degrees and less than 180 degrees. So we have to look at the solution range of the size of an angle of a sine curve between these values. So if A cannot be 60 degrees, then let's look at sine 90. Sine 90 also, what is sine 90? Will sine 90 give us 0.866? No, sine 90 will not give us 0.8660. Then what of sine 120 degree? Sine 120 degree will give us 0.8660. So sine 120 degree is 0.8660 as well. So we cannot say that since A is an obtuse angle, then A equals to 120 degree. And that gives us solution to this given problem. Now let's look at the past questions that we have here. Let's solve them one after the other. Okay, look at that triangle. It is a right angle triangle. Okay, so we have this. The diagram shows a right angle triangle ABC. Okay, AC equals to 15 centimeter and angle BAC is what? Is 38 degrees. Okay, now we have to calculate angle BC. So this is what we are calculating. So if you are calculating angle BC, that implies that if you look at it, the angle is facing this way. So this is the opposite. Okay, we have 15 to be the hypotenuse and we have AB to be adjacent. Now since we are looking for opposite and we have hypotenuse, so the best thing for us to use is swap, which is what? Sine theta equals to opposite over hypotenuse. Now from here, our theta is 38 degrees already, and opposite is, we don't know opposite, so let's make opposite BC, since that is what we are calculating, and our hypotenuse is going to be 15 centimeters. So that implies that we are cross multiplying sine 38 degree multiplied by 15 centimeter equals BC. Okay, so if we have that, then we cannot say sine 38 degree is going to give us 0.6157 after we approximate, multiplied by 15 centimeter equals BC. So if we have 0.617 multiplied by 15 centimeter equal BC. Okay, so BC is going to be what? BC is going to be 9.2349 centimeters. So let's quickly approximate that to 2 decimal places. So it's going to be 9.23 centimeters, and that's the solution for this. So the line BC is 9.23. Okay, now let's look at the next past question that we have here. If you look at this, we have a triangle here, but inside this triangle we have divided it into 2 different right angle triangle. Okay, so we have it to be, the diagram shows that we have triangle ABD and triangle BCD that's divided. Okay, so we have right angle triangle ABD and BCD. Okay, so AD is 5 centimeter. Okay, DC is what? 14 centimeter, and we have BAD to be what? 53 centimeters. So we have to calculate angle BC. So if we have to calculate angle BC, let's come and see what we have. So it's just, this is what we are having here. So we have it to be this. Okay, we are calculating angle what? Angle BC. So if that is the case, remember we have told us that we have this to be 53 degree. Okay, so we are going to be using, since we are looking for opposites, we are going to be using what we call tan theta. So we have tan theta equals to opposite over adjacent. So under this place, theta is going to be 53. So we have 53 equals to, okay, opposite is, we don't know, opposite is BC. So let's assume the opposite is X, divided by, we have 5 centimeter. Okay, so if that is the case, then we cross multiply, having cross multiplying, you find tan 53 multiplied by 5 centimeter equals S. So tan 53 will give us 1.3270 multiplied by 5 centimeter equals S. Okay, so 1.3270 multiplied by 5 centimeter will give us 6.6352 centimeter equals S. And that's the value for what? Value for BC. This takes us to the end of our class. I want you to subscribe to our channel www.edubbey.com for the full interactive content